Morning, students. This is Coach Primo at AQR for High School. Today we're going to go over and review units 8 or lessons 8 through 11 in unit 5 functions. Let's get right into it. Which chart does not model a step function? So we have to look at this arbitrarily. We have to understand what exactly we're looking at. So let's see if there's a correlation, first of all, to the number of people and the total cost in this first chart. Okay, if there's 6 people, it's $52. 9 people, $58. 12 people is $64. And then 15 people is $70. I'm going to get my handy-dandy little TI-84 calculator. Let's look for what might be considered some correlation. So what's the difference between the number of people, 6 and 9, on cost? It's a $6 difference. That's 3 people. You added $6 difference. 9 to 12 is 3 people and another $6 difference. And then 12 to 15 people, if you added 3 people, there's a $6 difference. So for every person, it's $2. Now, obviously, you're not going to have half a person, but there's definitely not a step function. If you were to plot this, you would see a linear function established. So we can go and look at the rest of them, but as you can see, A is already your answer. But let's look at the other ones. B, first class mail letter, 1 ounce is 55 cents, and first class mail letter for each additional ounce is 15 cents. Now that may seem linear, but here's the deal. You can have a fraction of an ounce. And if you have a fraction of an ounce, it's still going to be within that 1 ounce to less than 2 ounces level, and it's going to cost you 55 cents. But if you have 2 ounces or a fraction above 2 ounces but below 3 ounces, it will be a total of 70 cents and so on. Okay? You have a flat large envelope, and then each additional ounce is 15 cents more, and your postcard charge. That is a step function. Okay? So B, we're looking at the UPS next day air, and there's different zones per 100 pounds or more. This is cost per 100 pounds or per pound. Anything over 100 pounds is $1.70 a pound going to zone 102, $2.54 going to zone 103, and the rate goes up depending on which zone you're going. The cost really depends on the zone you're going to. So that rate is not dependent. It is linear when you're talking about per pound going to a different zone, but the zones are set up as a step function. You see the rate going to different areas costs more. How about the last one, the jeepney fare mix? You're curious what a jeepney is. You go to Micronesia or Indonesia and you want to travel, the taxis there are typically just bicycles with 2 seats in the back, and you sit in the back and you pay them a cost. And this is in, of course, the Filipino currency is the peso, just like Mexico, but because the Philippines used to be a colony of Spain. So anyway, the point being, so you've got 8 pesos to travel from 0 miles or 0 kilometers to up to 4 kilometers. And then anything over 4 kilometers, less than 5 kilometers is 925 pesos. 5 to 6 is 1050, 6 to 7, or more than 6 but less than 7 is 1175, and so on. That's obviously a step rate. Anywhere in between those mileages or kilometers, those distances, you pay that amount. All right, so let's go on to the next question. While driving through Terre Haute, Indiana, Coach Primo encountered traffic from 2 trains making his 20-mile drive to his hometown in Clinton uncommonly long. The following graphical display describes the distance to his home over the 3 parts of his trip. So what sort of function is this? We've got part of a linear function here up to the first 15 miles. Or 15 minutes, and then a linear function up to the next 30 minutes, and then the last 15 minutes was another linear function. While this isn't a step function, it is 3 separate linear functions. It's not a linear function because a linear function would be directly from this point 0, 20 to this point 45, 0. Actually, it is a piecewise function. It's obviously not a quadratic. There's no x squared in there. There's no curve to it. It's a series of connected linear functions, which makes it a piecewise function. So D is your answer. All right, in the first segment of the drive, Coach Primo drives at a rate of 3 miles per hour for 15 minutes. In the second segment of the drive, he travels at a rate of 5 miles per hour for 15 minutes. But in the last segment of the drive, he travels at a rate of 72 miles per hour for 15 minutes. What are the domain restrictions for the last segment of his drive? Okay, well, the domain is in time, and it's given in the statement. First 15 minutes, 3 miles an hour. Second 15 minutes, 5 miles per hour. Last 15 minutes, 72 miles per hour. Well, the last 15 minutes is 30 to 45 minutes, so that's your answer. C is your answer. C, 30 to 45 minutes. All right, question 4. A new prescription called Bug Eyes boasts a 24-hour guarantee of awakeness. Regular dose is 10 milligrams, but it has an 80% daily flush rate. Now, according to independent studies, as long as there is at least 2 milligrams in your system, there's a 90% chance you will remain awake. How long does a person have to wait until they must take another pill? Okay, well, if you take 10 milligrams and after 1 day, 80% of it is flushed out, what remains? 20%. Well, what is 20% of 10 milligrams? 10 times 0.2 is 2 milligrams. So you'll have 2 milligrams in your system. There'll be a 90% chance that you'll still be awake. So you're going to have to take another pill after 24 hours. So the answer is A. What function best represents the amount of Bug Eyes medicine remaining in the bloodstream over the first 24 hours? 10 milligrams with an 80% daily flush rate. That's going to be, let's look at the first one. Y equals 10 times 80 raised to the x. That's going to increase it every time you raise x, okay? Now, this is just over the first 24 hours. Well, you're not taking 80 milligrams, and that's your initial value, so B is eliminated right away. C and D look good. No, we're talking about an 80% flush rate, but we're going to find out after a day how much is remaining. So if 80% is gone, how much is remaining of the 100%? 20%. So 20% decimal equivalent is 0.2. So Y equals 10 times 0.2 raised to the x power. That's exactly what's it's going to look like. You don't even have to put the raised to the x power. Just the 10 times 0.2 is going to give you your answer. All right. What amount of Bug Eyes in milligrams remains in the bloodstream 24 hours after the first dose is taken and before the next dose is taken is obviously 2 milligrams. 20% of 10 milligrams is 2 milligrams. All right. How accurate is the Bug Eyes advertisement of a 24-hour guarantee of awakeness? Is it 100%, 90%, or 50%? Well, 24-hour guarantee, they only guarantee that a 90% effectiveness. You come back here, there's a 90% chance you'll remain awake as long as there's at least 2 milligrams in your system. But after 1 day, in 24 hours, you're going to have 2 milligrams. So they have a 90% claim. Okay? Question 8, if a person takes another Bug Eyes after 24 hours, will it keep them awake for another 24 hours? A, yes, but they will hallucinate about flying pink elephants all night long. Okay, there's no evidence that says that. B, no, the flush rate is too high to be dependable. C, yes, actually a bit longer, but only at a 90% effectiveness. Well, and no, it actually determined. So B and D are gone because yes is the answer, but are they going to hallucinate or will it actually a bit longer, but only at a 90% effectiveness? I think we can take the 90% effectiveness off because it only happens 90% of the time. 90% effectiveness only happens at 2 milligrams. But see, every day they lose 10%, so that actually is accurate because, or they're going to lose 80% of the milligrams. So regardless of what they do, it's gonna lose 80% of the medicine. So it's gonna get close to 2 milligrams every single day. So it's only gonna be 90% effectiveness until you take your next pill. Actually, a bit longer. It will ask you. It'll let you a little bit longer, but it only had 90% effectiveness. So that's your best answer, C. Not B, C. Question 9. If bug eyes is taken for daily for 5 days, what concentration remains in the bloodstream after the 5th dose? So let's take a look at this. I'm going to do this on my calculator, and I'm going to show you inside. I'm going to make this bigger so you can see me. All right. So we already established that the formula is 10 times 0.2. So 10 times 0.2. All right. Probably backwards for you, but I apologize. And I'm going to raise that. I'm going to add 10 to it. So that's going to signify the flush rate after a day, and then I'm going to take the next dose the next day. I'm going to enter. So I have 12 the next morning when I take my next dose. Okay? I've been awake for 24 hours. I take another dose to stay awake. All right? So I'm going to multiply that times 0.2 and add 10. So when you just hit times 2, it takes the last answer and it multiplies it times 2, and then I'm going to add 10. So that gives me the next day's dose. Day 3, when I take my next dose, it's going to be 12.4. And then when I hit enter, it's going to just replicate that same process, okay? So 12.48, 12.496, 12.4995, 5 days, 12.49984, so close to 12.5. There you go. What is the maximum concentration of bug eyes have taken daily? Obviously, just from this, if we were to continue going on this, if we were to just continue going, no matter how far we went, it'll never reach 12.5, or it'll get so close. There you go. Maximum will be 12.5. Notice it never goes over. All right? So the maximum on question 10 is going to be 12.5. So that's it for the review. Just 10 questions. We reviewed step and piecewise functions and concentrations of medicines. Hope you're prepared for this test. It's only 4 lessons. You should do well on this test. Do your best. In the meantime, folks, be blessed. Be a blessing.